In this problem, we are trying to figure out if given tree node is symmetric or not. So basically, if you put a mirror in between, if these values match each other, that means it's symmetric. If it doesn't match, like in here, that means it's not symmetric. So how are we going to solve this problem? We are going to traverse it level by level, and when we are traversing it, we will add these values to our queue, and we will add them at the same time, so left and right side of it. And what we're going to do is like we will be checking if they are equal to each other, and also if in cases of let's say it's like if it's in at 3 we have null point, it's pointing to null and null. If null values are equal to each other, like with this 3 and with this 3, they will be pointing to null. We'll be checking if these nulls are equal to each other, and wherever we are traversing, it's like if it doesn't match our criteria for symmetry, then we will just return false right away. So let's jump into coding. Creating queue for this, and we will be doing a linked list because we are also tracking null values. We want to add nulls as well. And we will start, like I was saying, from left and right. So if we take this example, we are storing 2 and 2. So roots left is 2, roots right is 2. So here we have 2 and 2. Now let's traverse while it's not empty. In here we will remove this 2 and 2 tree nodes that it is pointing to, all these things. So tree node left side of it, or we could just say list, and queue remove first because we are adding it to last, then removing it the first one. So this is a FIFO for queue, first in first out. So now in this example we have our left side is this one, right side is this one. What we are going to do, we will put some conditions in here. So first thing first, we want to take care when either of them or both of them are null. So if both of them are null, that means these nodes doesn't have any children. So in cases of where 3 and 3, 4 and 4, they're pointing to null and they don't have any children. So we can just continue with other nodes because there might be cases where this might be pointing to null, null, we check that out. The other one might have some other nodes, children, so we want to move on to other ones. And another condition is when, if in cases of one of them is null, that means it's a mismatch. So we could just return false from here. And since we took care of cases where it is null, now we can actually access the data itself. So left value, if it's not equals to right value. So in cases where this 3 and then if it's 5 here, so like they don't match each other, then we will return false right away. And now we need to add it back to our queue. Once we, let's say it's like this 2, we're at this one, so 2 and 2, we took care of all these cases, and we want to add these values back to our queue. So queue adding last. So when we are seeing this left of currently we're here, so current nodes left, we are adding that first, and then the corresponding, the symmetric side of it is a right, and when for this case queues, you wanna add them in order like this. So this left side's right will be symmetric to right side's left. Right side's left. And so we have cases where they don't equal to each other, or one of them could be null. If they don't meet these conditions, that means our binary tree is in symmetry. So let's run our code. So time complexity in this solution is O of n, where n is the total number of nodes in given binary tree, and space complexity we are using extra space q. So then it's also O of n, where n is all the nodes in a tree.